Our journey begins about 4.6 billion years ago with the formation of Earth. Born from the dust and gas surrounding the young sun, Earth was initially a molten ball with a hostile environment. Over time, it cooled to form a solid crust, and water vapor condensed to create oceans. This formed a primordial soup, setting the stage for life. The next step involved the formation of organic molecules. Amino acids, nucleotides, simple sugars, the basic building blocks of life, are thought to have formed spontaneously from simpler chemicals through natural processes. Experiments like the Miller-Urey experiment in 1953 support this idea, showing that organic compounds could be created in conditions that simulated the early Earth's atmosphere. But life needed more than just the right ingredients. These organic molecules needed to be concentrated and isolated. Deep-sea hydrothermal vents and small pools on land are both potential sites where this could have occurred. Enter RNA, or ribonucleic acid. RNA is believed to be one of the first macromolecules capable of storing genetic information and catalyzing chemical reactions. The RNA world hypothesis suggests that life based on RNA came before our current DNA and protein-based life. RNA molecules capable of self-replication would have been subject to natural selection, leading to the evolution of more complex and efficient systems. Eventually, DNA, or deoxyribonucleic acid, took over as the primary medium for storing genetic information. DNA is more stable than RNA, and its advent allowed for more complex genetic codes and, consequently, more complex organisms. The first living organisms needed a boundary to separate themselves from their environment. This was achieved through the formation of cell membranes made possible by lipids or fatty acids, which naturally form spheres in water, creating a simple cell membrane. Scientists believe that all life on Earth descended from a single common ancestor, known as Luca, which lived around 3.5 to 3.8 billion years ago. Evidence of early life comes from fossils of microorganisms found in ancient rocks and the genetic information encoded in the DNA of all living organisms today. From these simple beginnings, life diversified rapidly, especially after the evolution of photosynthesis, which increased the Earth's oxygen levels and led to the development of more complex life forms. This narrative is a simplified version of our current understanding of life's origins. Each step involves complex biochemical processes and is the subject of ongoing research and debate among scientists. The search for answers continues, as the mystery of life's origin remains one of the greatest questions in science.